Mr. Watson, could you please tell us a little bit about yourself, what you do, some of your accomplishments, and credentials?
Sure. My name is Will Watson. I've been with AM Equipment since May 11th as an employee, Vice President of Business Development. I was consulting for them back in January, and we got into a variety of different programs. And AM Equipment makes windshield wiper systems. They make motors, et cetera, et cetera. And I was reading in an article about windshield wiper motors being used for bridge ventilators. And I made a phone call to the University of Texas, and that's how this all happened. Prior to AM Equipment, I worked in South Africa on a clean energy project, taking CO2 and converting that into sodium bicarbonate. That was a project I worked on for about 3 or 4 years. Before that, I was doing some work on emission reduction for the heavy duty truck market. So I've got some experience on the medium duty side of things.
Thank you so much. And then obviously you already said who you represent, but why did you join the Bridge Ventilator Consortium and what was your role?
That's a good question. Well, I was given the name of Brian Wong by Dan over at the University of Texas, and I simply joined the consortium call on a Friday, I think it was. And when they realized that we were a ventilator or a wiper motor company, basically, and there's literally 150 or 200 different types of wiper motors out there. You go to AutoZone and get hundreds of them. But the trick is finding the right one, and the right one that'll last a long time. And so our motor is uniquely fits this application because it's a motor that lasts in north of 3 to 4 to 5 million cycles, because it works on buses, where the motor preferred for buses in Colombia, for example, buses in the United States, the FedEx vehicles. We're on these other types of applications that are yield these opportunities. So, but anyway, I got involved in that. To answer your question, I got involved in a conference call, and then he says, "Can you do a presentation for the whole group in a week?" And I was like, "Sure, why not?"
Yeah.
So, and then I got everybody together, and we all did this really cool Zoom call, and that's how I met the folks over at Virgin. And I just got off the line with the guy that Dan O'Connell that Brian turned me on to out of Hawaii.
Mm-hmm.
And so we're working on a program with them. And there's a group out of South Africa we're working on, Vistion in India we're working with, all from this. And so the volumes are significant. So I'm hoping that we can keep up.
Right. And then on that note, could you kind of comment on the type of wiper motor that would be like sufficiently reliable for a use in like an ambi-bag ventilator?
Sure. The model number for our wiper motor is called the 230 series. There's a variety of different kinds of motors, but the actuator has to go at a certain speed. So wiper motors have a high and a low speed. So you want to make sure they have a low speed. You want to make sure that it's a continuous motion operation, because some of the operations of the ventilators have a back and forth operation where you have the polarity and you reverse the polarity to make them go a different way. That's not the most efficient use of this particular wiper motor. Perhaps other motors can be used that way, but if you were to use it in a way where you could gear it accordingly, where it's continuously moving, that is an extraordinarily efficient way of using our motor, or any motor for that matter. But the difference between our motor and other motors that you buy at AutoZone is it's just robust, and the current draw and the voltage performance. We have the best torque versus current rating in the market right
Wow. So then, like in regards to extreme weather conditions, how would they hold up in high heat or
now. Really
humidity?
well. That's our bread and butter. I mean, we're on nurseries for robotics, for going out there and picking up plants. We're on exoskeletons. We're on FedEx trucks that go all the time. We're in Bogota, Colombia on buses.
Wow.
We're out in the military. We're just got a potential order for the Middle East. So when it comes to robust and really rough environments, that's where our motor shines.
So then you kind of touched upon this, but like what is the type of repeatability of a typical like windshield wiper motor? Like how
How
much?
long will it last?
Yeah, basically. I guess?
Yeah, that's a good question. And so, okay, so we tested this particular motor configuration a few years ago to see how long it would, how long it would take to fail. And just over 3 million cycles it failed. It took about,
Wow.
I want to say 5 weeks in continuous usage. But here's the trick. It failed in the high speed mode,
Hmm.
right? Remember I said to you, it said a high and a low speed. So it failed at the high speed mode. And when it did that, had it been used on a low speed, who knows how long it would go.
Hmm.
And that particular motor could have continued to be used on a low speed. Now, for the ventilator application, there is no high speed.
Hmm.
You'll never use the high speed side of things. So, to answer your question about how long will this thing last in a ventilator application, I don't know. I know it'll last longer than 3.5 million cycles. It might go 6, 7, 8, 9 million cycles. Who
Right.
knows?
Yeah.
But it will go a long way because the difference in wear and tear on the motor is unbelievably significant.
And then could you comment, like, generally, how expensive are they?
We have a manufacturer in Korea. That's our manufacturer that does it in Korea.
Hmm.
But it's a very specific design, proprietary, and all that. So, but when it comes to price, that one was an interesting one. You guys were, or not you guys, but ventilator folks were buying automotive style parts, and so they were paying, I think, $38, $39 for a ventilator motor or for a wiper motor, something like that. So this motor that I'm talking about costs about $140 out there in the open marketplace. But that said, in this application, and because of a lot of other factors, we figured out a way to price it a different way. So the price point for this motor, if we were looking at, let's say, 3,000 units a year or more, I think the price right now on the open source is $43.20. So that's just a little bit higher than 38,
Hmm.
but it's I think it's totally reasonable with respect to what you're getting.
Yeah.
Not $140. Not because the whole idea, right? As I understand it, is to get the whole system to be
Would
marketed
be
to less than
affordable.
$1,000,
Yeah.
right?
Yeah.
So we want to contribute to as much as we can to that end, and so 43.20 seemed to be a really good price.
Hmm.
And But the other thing about this motor is that you'll see that there's uh, as I mentioned, there are automotive type motors, and then there's the robotics medical type motors. We're in that band that's just above the automotive and just below the real expensive ones. Because you can get a motor that can cost you 500, 600, 800, $1,000, depending.
Hmm.
So when it all comes down to it, our motor is very, very unique.
What would you say is the easiest way to control a windshield wiper? Like, do they operate in open loop configuration, or like what type of circuitry would be necessary to operate them like outside of a car?
Engineering group, but I can answer it in such a way that you want to have continuous operation. You want to have it geared accordingly. So the best way is for the motor to be rotating all the time, and for the gear mechanism and the linkage to be operating in a certain way, so the wipers can do what they need to do. So a lot of it has to do with not so much the motor as it does the linkage.
Okay.
So the linkage is just as important as the motor from a wiper manufacturing perspective.
Oh,
So, but a more detailed answer could be given later.
right. Okay. Are there any wiper motors with a built-in encoder, such as one would know like the position of a said wiper motor at a given moment and time?
Yes, we have one.
Yeah.
It's called a mag pickup.
Magnet.
And we have that, yes.
Okay. And
Yeah,
then
that's an option available. It's obviously more expensive, but we have that option.
right. If need be, can wiper motors be sterilized, perhaps when an ambu bag is removed and replaced after and in between uses by different
That
people?
depends.
That
That
depends.
depends on what's it being sterilized with and how.
Hmm.
If it's being sterilized, in an alcohol bath, and if it's not sealed, it could be an issue.
Hmm.
If it's sterilized through an air sterilized system, like you would CPAP machine, for example, probably shouldn't be a problem at all.
Right.
Our motors are designed to be splashed and hit and all that kind of stuff. So I don't foresee that being an issue at all. I think it's more a matter of how the sterilization process is done.
Hmm. So, okay, yeah, that makes sense. Or sorry, if you're using a windshield wiper motor to like mechanically deform a medium tensile strength plastic, what type of total torque generated by the motor would we anticipate, and how stable is the torque generation temporally?
I don't know the specific answer to that question. I know that the torque ratio of our motor relative to the current requirements, because it's all relative to current, right? So the
Yeah.
amount of current you provide the motor will give you the amount of torque.
Yeah.
And our torque relationship is the minimal, we have so much torque availability. So it's on a curve. So we can torque over as much as you want. And
Mhm.
so that's not an issue. But the specifics to what you're asking has to do with the durometer of the factor of the bag as well. So what is the hardness of the bag? In other words, what's the flexibility? So we don't manufacture the ventilators per se, but specifically to answer your question relative to torque, we can give you torque curves
Mhm.
and you can apply those torque curves to your application.
Okay.
That might
Um,
be a better way of doing it.
yeah. And then how do you feel that the BBC has provided you with like sources otherwise unobtainable through your current network?
The what?
Like
Repeat that again?
how would you say that the bridge ventilator has like given you resources that you wouldn't otherwise like have been attainable?
Well, it's another aspect. It's a unique application for a motor that we sell already in the wiper configurations around the world. And it's also a way for us to help combat this unbelievably horrible thing that's happening to the world. And so the fact that we as a company can contribute to this is a pretty big deal. And that's why we're able to do this price point. We want to do it. That's part of it. And we're into it. And so that's the gift that it gives us, I guess. I don't want to call it a gift, but I mean, and there's obviously there's a lot of work involved. I mean, the volumes I heard literally 10 minutes ago, I was on a phone call and I said, "What are you thinking of as far as volumes?" And they were telling me north of 100,000 units.
Wow.
That's a lot.
Yeah.
That's a lot of units, and that's going to take a lot of work to get that involved. So,
Yeah. And then is there anything else you would like to add or comment on?
um, I'm assuming this is going to go on a website. People are going to be able to see this and be able to communicate. So I guess the most important thing is for people to know to get a hold of us. One of the things I realized, and that's part of my job moving forward as the head of marketing, is to ensure that when people type it in their SEOs on Google, they can find us correctly.
Mhm.
So right now, if you were to type in ventilator, motor, or whatever, you may not see AM equipment on there. So I would ask that amequipment.com, would be on your website, and
Yeah.
certainly you can give them, communicate my phone number to everybody or whatever. I don't know if I'm appropriate to say that now or whatever, but I mean, I'm happy to support whatever needed. But that's the main thing, is making sure that the folks that you guys are in touch with are understand how to get a hold of us and vice versa.
Right. Thank you so much for answering my questions.
You're welcome.